Okay, for this video we're going to talk about compound inequalities. So if you look at your foldable, you're looking at two different versions. There's either the ones that involve and the ones that involve or. Now if you look at this one, the 17 is less than or equal to 2x plus 7 and at the same time less than or equal to 29. This is the inequality that involves and. Now how do we solve this? There's two ways to look at it. What I would do is I'd set this up as 17 is less than 2x plus 7 and 2x plus 7 is less than or equal to 29. Now if you go ahead and we solve this one right here, we're going to subtract 7. Subtract 7, we get 10 is less than or equal to 2x. We go ahead and divide it by 2, we divide it by 2. You get 5 is less than or equal to x, but we don't like that. We're going to write that as x. Put your 5 over here, and that's greater than or equal to 5. The other one, you subtract 7. Subtract 7. 2x is less than, so 2x is less than 22. You divide by 2. And you get x is less than or equal to 11. Now how does this look like? What does this look like on the graph? Well, that's pretty simple. On a graph, you have x is greater than or equal to 5, and at the same time x is less than or equal to, and at the same time x is less than or equal to 11. So on the graph, you would go ahead and you could say that here is 5, it's a solid circle and it's going to go that way, and here is 11, it's a solid circle and it's going to go that way, so they come together. That is the ones that involve and. Okay, look at the next one. You have 3t minus 5 is less than negative 8, or 2t plus 5 is greater than 17. Now in this one, what you're going to want to do is, if we look at just the 3t minus 5 is less than negative 8, we solve it. We add 5, we add 5. You get 3t is less than negative 3, divide by 3, and you divide this by 3, and so you get t is less than negative 1. We didn't have to change our sign this time because we didn't multiply or divide by a negative. If you look at this one, we subtract negative 5, you get 2t is greater than 12. Divide both sides by 2, you get t is greater than 6. So this is t is less than negative 1 or t is greater than 6. How would that look like? So you have t is less than negative 1 or t is greater than 6. So how this looks, you draw your number line. You have a negative 1, that's an open circle and it goes that way. And here is your 6, it's an open circle and it goes that way. So that's the examples of and the examples of or. That basically covers the compound inequalities, but we need to look at the next thing, which is, now when we talk about intervals, what we're talking about is open, closed, and half open or half closed. When you look at these, you know it's closed because of those brackets right there. When you look at the opens, you know that they're open because you see the parentheses right there. Half open and half open left or half open right, that basically is just how you have one parentheses and one bracket, and then a bracket and a parentheses. Now how you write these things in set notation would be like the compound inequalities. So let's take a look at a couple examples here. What is the graph of negative 4 comma 6? Well, we know that negative 4 comma 6, this right here would be anything between negative 4 and 6. With the bracket, with the bracket right there, that means it's inclusive, like a closed circle, and with the parentheses, it's open circle. So the graph would look something like this. You put a negative 4 right here, put a solid dot, put a 6 right here, and open circle, and you go like that. So it's kind of like the and that you see. Moving on, if we had to write this as an inequality, you could write this as x such that negative 4 is less than or equal to x is less than 6. Why is it less than or equal to? That's because of the solid bracket right there. Why is it less than? That's because of the parentheses. It's a little more practice and I think you'll be okay. Hopefully this makes sense, and I look forward to seeing you in class tomorrow, and may the force be with you.